All right, we're going to talk about circles today. And circles are everywhere you turn. Think about the wheel that's on your vehicle. It makes revolutions. So as it is turning or revolving, that is actually how your speedometer works. It's based on how many revolutions you make. There's a formula to determine how fast you're going. And that revolution is actually called the circumference of the circle. So take a second and draw a pretty neat circle. Make it fairly large so that we can diagram it, maybe like 6 or 7 lines long. And I'm going to put a center. Right in the center, I'm going to put a dot. And the first term I want you guys to know is a chord. And I like to play guitar chords, but here we just have a chord is just going to be a line segment with endpoints on the circle. So the chord is a line segment with endpoints on the circle. All right? Another thing I want to talk about is the radius. Radius is if you go from the center to the edge of the circle. So I'm going to call that my radius. It's the segment from the outside of the circle to the center. All right, so the radius is the segment from the outside of the circle to the center. And one more term here. What if we go all the way through the center? So a chord that goes all the way through, that's the diameter. And that's when a chord passes through the center, and the prefix di right there isn't morbid. It actually means 2 of the radius. So for instance, if you knew the radius was 5, then you know the diameter would have to be 10. Or if you knew the diameter was 16, the radius would have to be half of that, which would be 8. So if you know one, you can find the other. All right, take a second, pause the video if you need to. And we're going to go back to our wheel example. All right, back to the wheel. Think of our wheel as we make one complete revolution or one complete turn. That's actually called the circumference of the circle. And again, that's how your speedometer works, to tell you how fast you're going. It's how many revolutions you're making in a certain amount of time. All right, and one revolution is the circumference or the distance around the circle. And there's an easy way to remember this. And that memory tool is cherry pie is delicious. And this is how that works. Cherry pie, pi meaning the pi symbol or 3.14, delicious. And D stands for the diameter. So let's write that formula down, C equals pi d, and make sure that we label what each of these mean. So C is our circumference. Our pi is like P-I-E, but it's P-I when we use the pi symbol, is 3.14 about, and then D is our diameter. So cherry pie delicious. And personally, I'm an apple pie guy, but hey, cherry pies can be good too, right? No, you don't think so? I can't blame you. Anyway, just remember that cherry pie delicious for the formula. You don't have to like cherry pie. All right, I want to make sure that you guys understand what pi really means, because pi is the ratio of something. Let's figure out what that is. If I wanted to solve for pi, I'm just doing a one-step equation. I would divide by the diameter divided by the diameter, and that's what pi would be. Pi is just the circumference over the diameter. In other words, the distance around the circle divided by the distance through the center of the circle. So that distance in red is about 3.14 times bigger than the distance in blue here. And that ratio always holds true, no matter if your circle is really tiny, or really big, or extremely big. It's always the same relationship. The distance around the circle is always going to be 3.14 times bigger than the distance through the center of the circle. Pretty cool, right? All right, let's try an application problem. Let's say, for example 1, our radius, when I use r, I mean radius. Our radius is 5. Find our capital C, and C means circumference. I'm going to start by writing down my formula, which is C equals pi d, cherry pie delicious. Oh, I found an issue. I have an R, but I need a D. So I can plug in C equals pi, but I don't have my D. Well, think back what we talked about earlier. The radius is halfway across. The diameter is all the way across. So if I know halfway across is 5, then that means all the way across has to be another 5. So 5 plus 5 is 10. So the diameter has to be 10. I'm going to write that off to the side. And then I'm going to plug it in. So our circumference is 10 pi. And 10 times pi is going to be 10 times 3.14. And actually pi continues to go on and on. It never stops or repeats. There's a whole bunch of digits. But just for the sake of sanity, we're going to round it to the hundredth spot. All right. So if I multiply by 10, all I need to do is move the decimal over 1 to the right. So it's just going to be 31.4 units. All right, finish up with that. And now we're going to jump over to circle graphs. Circle graphs are a great way to show a survey, the results from a survey. So circle graphs show a visual display of parts of a whole, example, a survey. And when we make central angles are part of a circle graph. So we, in order to figure out how big to make them, based on the percentage of people voting a certain way, then we need to figure out the degrees. So angles from the center of the circle represent our central angles. And how many degrees are in a circle? Oh, you shouldn't have to think that hard about it. You know that a straight line represents 180. So a circle is just another straight line, or another straight angle. So 180 plus 180 gives us 360. All right, so since we know there are 360 degrees in a circle, we can use a proportion to find out the number of degrees or the percent represented by a circle graph. So percent over 100 equals degrees over 360. In other words, just part over whole. All right, so let's do an example on that. A favorite cookie survey was conducted. Wait, where'd you go? Oh, you had to take a cookie break, did you? Nom, 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 nom. All right, glad you can make it back after your break. Jeez. Okay, so 30% like peanut butter, 20% like sugar cookies. Then how many percent would like chocolate chip? What do you think? Well, these need to add up to what? 100. And we already have 30 plus 20, which is 50. So 100 minus 50, that has to be 50%. So 50% like chocolate chip cookies. Hey, I like chocolate chip cookies. Feel free to bring in some for me. All right, so can we make a circle graph to represent this situation? And normally we would use a protractor to do this. I'm going to draw a circle, taking up a few spaces off to the right. I'm going to have a center there. And you always start just by drawing the radius there. And I'm just going to eyeball it here, just so you can get the concept. But we're going to do the calculations off to the side. So for instance, let's start with our peanut butter. 30% like peanut butter. I'm going to use this proportion up here, so 30 goes up to the top. So it would be 30 out of 100 equals my degrees, which I don't know, so I'm going to call that x degrees, out of a total of 360. All right. I'm going to show you a shortcut. Sound good? Well, normally we could just cross multiply and do 100x equals 30 times 360. But that's going to be a huge number, and I want to see if I can do this a little simpler. So bear with me. I'm going to make equivalent fractions by canceling out these zeros. How did I do that? I just divided them both by 10. So dividing 30 by 10, dividing 100 by 10 actually gets rid of those zeros. So now it's 3/10. How does that help me? Well, 10 will go evenly into 36. 10 times 36 is 360. Do the same thing to the top, and x is just going to be 3 times 36. 3 times 30 is 90, 3 times 6 is 18, so 90 plus 18 is 108. So x equals 108 degrees. And that's peanut butter. So 108 degrees, well that's 90 if it's straight up and down. So it's just going to be a little bit more than that. Maybe about like that. So I'm going to write peanut butter inside of there. And then I'm going to do the calculations for the next one. So 20% like sugar, so that would be 20 out of 100 equals the degrees, which I don't know, so I call that x degrees out of 360. And we can use that shortcut again. The zeros at the end of 20 and 100 divide by 10 and they disappear. And now 10 will go evenly into 360 by multiplying by 36. Whatever you do to the bottom, do to the top. So 2 times 36, that's pretty easy. Just 36 plus 36, which is 72. So x equals 72 degrees for the sugar cookies. And now a 72-degree angle, I'm going to draw that from my, you can draw it from either one, but I'm just going to do it from the bottom one. Nah, I changed my mind. 72 degrees is basically going to be less than 90 but more than 45. That would be 45. So it's about, yeah, it's about right there. So this represents my 72 degree, which is sugar, that whole region. All right, and we should have the remaining should just be chocolate chip, but we should always do it just to check our work. So it should be about 50 is what we have there, which is how many degrees do you think? Yeah, half of 360 is 180. So 50 over 100 equals x over 36. I can do the same thing, or I could reduce 50 out of 100 to, I could even make this simpler. Cross that off and make it 1 over 2, because 50 is half of 100. And then 2 will go into 36 18 times. 1 times 18 gives us 18 for x. And I obviously forgot this 0, whoops. So it would be 180, my bad. I'm glad I caught that. So 2 times 180 is 360. 1 times 180 is I said 18 earlier, I meant 180 degrees. And that's our chocolate chip. Got to watch those zeros. And chocolate chip is 180 degrees, which is 50%. That makes sense. All right, hope you enjoyed your cookie. Have a great day. And I almost forgot, check by adding up the degrees, it should equal 360. So for instance, our 108 plus our 72 plus our 180 better equal 360 when we add them up. And sure enough, they do. So it checks. Nom 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 nom.